Hello friend, welcome to my YouTube channel Electrical Boost. In our previous video, we understand the difference between AC and DC circuit, how the signal behavior in the AC and DC. Now it's time to explore the fundamental building block of every analog circuit, that is called passive component. Okay. In this episode, we will clearly understand three main components. What are the three main passive components? The resistor. Okay. Resistor. Second one is the capacitor. Next is the inductor. These are the three basic components, which passive component which are going to use in our analog circuit design or every hardware design. Okay, then how they behave, then this circuit how they behave in DC and AC, how the resistor will behave in AC and DC, and all like this, AC and DC. First, before going to the individual component, first we know what are the passive component, or what do you mean by the passive component. What is passive components? Okay, what is passive component? Before we start with the individual component, first we go to the what is the passive component and what is the real meaning. Okay, passive component are those who do not produce. Passive component are those. Passive components are those which do not produce or amplify the electrical power. The passive component, what is this? If which component will not produce or amplify electric power, which can you tell for active this one, any power required, like that MOSFET, you know, that is required some power to externally to active that one. Okay, or amplify. Okay, instead they are what they're doing, instead they're producing the amplify electric power, they either store or dissipate or oppose electrical energy. In simple word, the resistor always dissipate energy or consume the energy. It can dissipate energy, consume energy. Like this, capacitor, what they doing? Capacitor is always what? Store energy in form of electric field. And inductor, what they doing? Inductor always store energy in form of magnetic field. magnetic field. Okay, due to those property, we can going to use this circuit or this component in our analog circuit, or digital any hardware design in electrical electronics uses. First, overall you know what is the passive component, you know. Then after that, what is the basic fundamental three component, you know. Then we go depth about the one by one component. First component is, you maybe know about the resistor somehow. Resistor, what is the work of the resistor? It's the component. It is oppose the flow of electric current, in it, or you can tell it limit the amount of current. It can limit the oppose means that limit. Suppose you think like the tap. Suppose you connect the tap, na. What will happen when you close the valve? The water flow is not going on. So like this, when you suppose this is resistor just like valve. When you increase the resistance, the current what amount will decrease. When the resistance increase, current decrease. Okay, this is derived from the formula Ohm's law, V equal to I into R. Okay, into R. That is basically denoted by R, and its unit is Ohm. The symbolical reference of resistor is like this. If you go design the circuit, then you can go use this symbol. This is simple resistor. So many types of resistor are there. After some video we will discuss while designing the circuit. Okay, then we know how it behave in DC and how it behave in AC. Actually in DC what happened? The resistor drop the voltage. Resistor what happened? Resistor drop the voltage. By dropping the voltage, it can limit the current. In AC case, in the resistive circuit, the current and voltage always in phase. Suppose this AC, na. Suppose the voltage waveform like this. If we draw across the resistor, that is also follow the same. If this is the voltage, this is the current. Okay, always in phase. Where to use this circuit in our case? Suppose somewhere we are going to connect LED. That is LED having some current limit. Okay, so that we can put one series resistor. After that we connect the LED. Then it will what to do? It will limit the current, so that LED smoothly operate. Suppose we increase the current, then what happen? Then LED will gone or something damage. Okay, then somewhere in pull of resistor, pull of concept we later know what is the pull of resistor or pull of concept. Next, somewhere sensing the current sensor. By using some series resistor, we can calculate how much current is flowing. Suppose we know the voltage and the resistance, then how much current will flow. It can use as current sensor. This is the practical example we are going to use in electronic circuit. Here you can see the video. There I connect one simulation diagram. Here I connect one resistor with series with LED. That is when the increase the resistance, the current is decreased. You can monitor that current when the resistor is going to increase, that time the current also increase. When I decrease the resistance, then current will increase and LED is blown off. Okay. Next we are going to another second component, that is called capacitor. That is called capacitor. That is called another is capacitor. Capacitor is simply, what is the work of capacitor? Capacitor is store energy in form of electric field, electric field. It basically consists of two conducting plate in between one dielectric medium, one dielectric medium. This is the dielectric or dielectric component or material with two conducting. One side is positive like this coming. If you more know about the capacitor, you can go our previous video. There is I explain more depthly about the capacitor. By separate the dielectric, it denoted by letter C. It is denoted by C, and the unit is farad. You know what is the blocking or resistive or inductive or capacitive reactance? Capacitive reactance, that is the basically the blocking capacity of the capacitor. Okay, that is X equal to 1 by 2 pi Fc. Due to this, when you apply DC, you know already DC having zero frequency or 0 hertz. When it is 0 hertz, then what happen? This Xc inductive, this is 0, then total term is Xc equal to going to infinity. That means when you give the DC supply, it always block the DC. Maybe initially it will charge. When it is full charge or store energy, after that they will block. You know that capacitor always transient it can allow, but constant it not allow. Okay, when it is changing, initially it will charge, after that it will block. The current. Okay, block the current. This is for this reason we are going to use somewhere in the filter case. In the filter we can use an amplifier, coupling capacitor. Okay, timing circuit we can use this one. Okay, next filter circuit we can use this one. Okay, this is called temporary energy store. When you high frequency, that time it will allow, but in low frequency it will block, means DC. Suppose filter case, when you giving DC, if inside DC something will come, some noise or something, the AC component come, that time what happen? If you connected short arm capacitor, whatever the AC value, that will discharge through this one, and pure DC will going to main circuit. That is best example of this one. Okay, some we are going to use the timing circuit, and our microcontroller, the required oscillator. So this way we are going to use this one. Okay, next this is all about the capacitor. We are just overall going. Okay, while the combination of the circuit, then it will can enjoy that level of the component. Okay, next we are going to check what is the inductor. In inductor, basically it store energy in form of magnetic field, in form of magnetic field, okay, in form of magnetic field. What it is, its property little bit opposed to the capacitor. In the capacitor, what you know, it will block DC and allow AC. Here it little bit opposite. It will, if any change occur, then it will oppose. If constant, then it is allow. It is constant, then it is allow. How? In the inductive reactance, XL equal to 2 pi FL. Here frequency suppose high means suppose high frequency, that time it will what happen, it will some inductive reactance, so that it will oppose. In case of DC, that is zero reactance means it can allow easily. Here basically in the inductor, it's represented by L, and its unit is Henry, or you can represent as H, and it's symbolically just a coil or choke, like this symbolically represent. Where this is basically used, it can also use in filter, that is like that, in series it connect, so that it can allow the DC, and what are the AC component that can drop, okay, not allowed. Then somewhere in the RF circuit, radio frequency circuit, we can use this inductor, we can use the RF network. In the later chapter we are going to discuss what are the circuit. By using some example of overall 3 combination, we can use the RC network for the timing circuit. Remember, if you are interested, we can go through this one also in the next video or some later video. Some LC filter, this one can LC filter, you can check. This is the LC filter. Some RLC network through the circuit, radio frequency, okay. This is the practical example of this 3 passive component. Another passive component is the, you can control a transformer, but this is called device, not a component exactly, okay. This is overall about the passive component. How in later chapter, how going to use this component in our design circuit, we can discuss, okay. Thank you for all for this. In our next video, we are going to learn what is the passive component, or sorry, not passive, that is active component, or some like the semiconductor component, like that MOSFET, transistor, BJT, overall knowledge, okay. I hope you like the video. Thank you for watching this video. Please like and subscribe. Thank you again.